Okay, and we're live. Okay, so we should have a handout. And what it has on it are lists of ions, but the main thing that I want to look at today are these things called polyatomic ions. Okay, so looking at the English here, polyatomic. What's the prefix poly refer to? Many. Many, yeah. Atomic, atoms. So these are many atom ions, meaning that the ions contain more than one type of atom. Okay? So there's actually only one polyatomic cation in here, as you can see, and that is ammonium, NH4. Okay, so that itself is the polyatomic cation. Itself, it has a charge of +1. So this is the ion, and this is the charge of the ion, okay? A lot of common mistakes that I've seen in the past is that students think, well, the nitrogen must have one charge and the hydrogen must have the +1 charge. That's not the case. The whole thing is the ion, and the whole thing has the charge of whatever is listed in the sheet there. So ammonium is the ion, the charge of that ammonium ion is +1. Okay. Oxalate is C2O4, so that's the negative ion, and that negative ion has a charge of -2. Okay. So, like in the ionic compounds that we've done before for formulas, the whole goal is still to balance out the charges. Okay, so that remains the same. Now, there's a new little twist with this in terms of writing the formula, but really, if you think about it, all it's doing is it's showing, like in math, your properties, how you would do things in math. So to show that you have something that is like a distributive property, you put parentheses around the ion to show that there's more than one of them. So when I write out the formula between ammonium and oxalate, I write NH4 first. I put the parentheses around it because I know I'm going to need more than one of them. Okay, in fact, specifically, since only one has a charge of +1, and I'm going to need to have two of them to balance out the charge of the one oxalate, then, after I put in the parentheses, I can put in 2. Okay? So then all together, that tells me I have 2 ammonium ions, which altogether out of that, if I'm counting atoms, I'd have 8 hydrogen atoms and 2 nitrogen atoms. See that? In other words, the 2 distributes into the NH4 if you're counting total number of atoms, which later on in the back side of the assignment, I'll show you that. Okay? Now the oxalate, I only need one of them. So if I only need one of a polyatomic ion, I can just write out the polyatomic ion as it is, C2O4. So this would be the formula for ammonium oxalate. Now the cool thing about this too is when writing out chemical formulas that contain polyatomic ions, you don't have to worry about modifying anything. Find it on your list, write the name of the ion as is. So NH4 ammonium oxalate. Ammonium oxalate. So NH4 is ammonium, the C2O4 is oxalate. I just name them as they are. If I had, now if I just have, let's say if I have a singular ion with a polyatomic ion. I'll take the NH4 example and we'll use this one again here. So let's say if I've got ammonium NH4 and chlorine, which is a charge of -1. Now the nice thing about that is it evens right out. Don't even have to worry about parentheses this time. So I can write it out as NH4 Cl, but again, since this right here, Cl, is its own monoatomic ion. I follow the rules just like what we were doing before since it's a singular ion. The second one, you add the IDE to it. So then ammonium chloride. Ammonium chloride. And I'm going to take this example and I'll give you one that just has a singular positive ion in it.
So
Okay.
singular negative, then you add the IED
Mhm.
or IDE.
Correct, yep. Now for a singular positive then, say we have sodium, Na, and then we have this other polyatomic ion called hydrogen carbonate, which is HCO3 that has a charge of a -1. Okay, put them together, the charges balance out nice and easy. So Na and then HCO3, well, the singular positive ion, I name it just as I would before, and I don't have to do any endings, just like what we were discussing from the assignment that you did for today. So sodium. And this actually has two names. It doesn't matter which one you call it. You can either call it hydrogen carbonate, or the common name is bicarbonate for the ion. Actually, sodium bicarbonate is a common household chemical.
Isn't it?
Baking soda.
Baking soda, yeah. Sodium bicarbonate, baking soda. Yeah. Yep, it keeps your refrigerator smelling nice. Use it to make cookies, brownies, whatever else, etc. So, yep, that's sodium bicarbonate. So yeah, if you have a singular positive ion, just like what we were doing in the ionic compounds assignment, the first one you name without changing anything. The polyatomic ion you name as you see on the sheet. The only thing you actually have to change in terms of names is the second one from like what you were doing before. So the -1 gets changed if it's singular. Okay. So it's just a matter of keeping track of those. Okay, so that I think takes care of in terms of the ideas of what you need to do. So again, if you have more than one of a polyatomic ion, put the parentheses around it before you put numbers, after it. So put the parentheses around it, and then, like 2 or 3 or 4, how many ever of them that you need. Let's see if I can come up with one more example of that. How about aluminum, which has a charge of +3, and then sulfate, SO4, which has a charge of -2. Okay. So that means I'm going to need 2 aluminums, 3 sulfurs in order to balance those out. So Al2 and then SO4, put the parentheses around it, 3. So I need 3 sulfates to balance out the charge of 2 aluminums. And then in terms of the name, aluminum sulfate. Sorry about that. I believe for our purposes, the only positive polyatomic ion that we have to deal with is ammonium. Everything else is a negative ion. So really those are kind of the two things that you just need to highlight there are polyatomic cation and the polyatomic anions. You probably do notice they give you some other information in there too, but you can also find that same information in your periodic table. Remember, all you got to do is look at the oxidation state, and that tells you what the positive or negative charge of it is. Or if you happen to remember which column it comes from, like column 1A, +1, column 2A, +2, and so on. And again, remember with the transition elements in terms of the Roman numerals from the assignment that we did the other day, if you're looking at any elements in the center of the table, check out the oxidation number for it. If it's got more than one oxidation state, then you have to use that Roman numeral to name it. So like, remember copper, copper plus 1 would be copper 1 when you name it, or copper 2 is copper Roman numeral 2, and I think that one is actually in your chart there. Yep, it is. But obviously there's more than just that, so make sure that you refer to your periodic table for any of those. Okay, now for that drawing part that you see, like number 1, number 2, number 3. Why don't we take a look first at number 2. It has Fe2 plus and Cl minus. Okay. So the Fe2 plus is one of your ions. Cl minus is your other ion. Okay. So then for drawing out the ions, all you're doing is you're just, as they're shown in number 1 there, you're drawing little circles with the charge. You could either draw this as 2 plus to show the iron. Excuse me. The way I tend to like to do it is I write out the symbol for the element, and then I put the 2 plus next to it, and then I draw the circle, just so that way it tells me what it is. You can do either way, whatever feels more comfortable. So then the Cl minus is the other element. Now, because this is positive 2 and this is negative 1, means I'm going to need a second one. So then, as I draw out the compound, okay, I can show my 2 chlorines attaching to my 1 iron. Because as we know, positive attracts negative, and vice versa, negatives attract positive. So then in terms of the formula would be FeCl2. And then for the name, so as you can see from either the periodic table, when you find iron in the periodic table, I think you can have charges of 2, 3, and 6, if I recall correctly. So that means we gotta name it according to which ion that we used. We used the iron with the plus 2 charge. So then iron 2 chloride. Okay, and that's how we name that one. Okay, and as you see in number 3, the polyatomic ions, they're treating a touch differently there, because you notice how there's like a dashed line around the sulfate. So they're showing you there that the sulfate itself is the ion that has the charge of the -2, and then they put the dashes around it to show that it's like one unit. It's an entire ion on its own. So that's what the dashed lines are for. Tell you what, take a look on the second page, number 11. Number 11. We have silver and chromate, and here's where that really starts to come into play to help you in deciphering those ideas. Okay, silver in the periodic table is number 47. It only has a charge of +1. Chromate is CrO4, and I believe it's a charge of -2. Just need to check that, and it is. Okay, so when we draw out the the ions then, so you'd have an Ag with a plus charge, and then the CrO4, you'd have a chromium element with 1, 2, 3, 4 oxygens attached to it. So that's the chromate ion. And the dashed line is representing that this is a polyatomic ion, and that polyatomic ion has a charge of -2. So that means I have to have one more silver that's going to be attached to it in order to balance out the charges. So then when I draw out the compound, my formula first, Ag2CrO4, and for the compound, actually, I'm not even going to draw that in here. I'll just attach them. So Ag, and there's my compound. So I've got a silver, and 1 chromate. Okay, so then when we're counting ions, how many ions do I have here? Nope, not 2. So this is an ion, and both of these are ions, 3. So I've got 2 silver ions, 1 chromate ion. So altogether, for the ions, I have 3 ions. Okay, now for atoms, I'm counting out each individual oxygen, chromium, and silver. Huh? 7, yep. 1, 2, 3, 4, 5, 6, 7. 7 atoms. Obviously only 3 ions because, again, this is a polyatomic ion, so it's 1 ion that actually contains 5 atoms. So 1 ion, but yet 5 atoms in the ion. And then obviously each of the silvers is its own monoatomic ion. Okay? You want one more? Should we do one more of these? Okay. Let's try calcium sulfate.
Is there always 4 oxygen atoms?
Sorry, what?
Is there always 4 oxygen atoms on a sulfate or something?
On chromate, yeah. On that's actually, yeah. It's if I remember correctly, if it's an 8 ATE, it does have 4 oxygen atoms. If it's an ITE, I believe it has 3. And that's not that you have to remember that, but that's a little general trick from college camp if you want to use that. Okay, so sulfate is SO4, calcium is Ca, so in terms of the formula, the charges balance out. Ca, SO4, calcium sulfate, and then for drawing it out, I'm going to have a Ca with a +2 charge, and SO4, with a -2 charge. So then, when I put them together, as we know, there's going to be 1 of each to balance out the charges. So that means altogether, I have 2 ions. Then in terms of atoms, 1, 2, 3, 4, 5, 6 atoms. Because I have 1 sulfur, 4 oxygens, which makes 5, and then the 1 calcium atom, 6. So 6 atoms, but only 2 ions, because again, the sulfate actually contains 5 atoms in its 1 ion. Okay. All right. Anything else to look at on this assignment before I kind of set you free on it? Does that make sense in terms of how to write out the formulas if you need, parentheses and how to name them, and for this assignment, I do want you to do the drawings. If that, because I figure number one, that'll probably help you going on, but if it's something that you decide, well, it's a big pain in the butt and, you know, it doesn't really help you, you don't have to do it after this assignment, but I at least want you to try it for this assignment, okay? So, why don't we call it good there? I'll turn off the video, and obviously you guys can work, and I can assist you the rest of the way.